Okay, this video goes with the 1-4 additional practice, and let's see what we got. So for this first one, for exercises 1 and 2, find the pattern for each sequence. So let's look and see what we got. Probably first thing I want to do is look for differences. There's a 6 difference there, 7 difference there, 8 difference there, 6, 7, 8, 9 is the next one. That's going to give us a 35. 10 is the next one. That's going to give us a 45. And then 11, we'd have 56 if we want another one. So the pattern is, it keeps increasing by 1. By 1 more each term. Okay, let's look at number 2. B, D, F, H, J. Oh, let's see. So let's try maybe the difference between the letters B, C, D. B, C, D. 2 more to get to D. D, E, F. 2 more to get to F. F, G, H. 2 more to get to H. So it looks like the jumps are 2 between the letters. H, I, J, 2. K, L. Wait, H, I, J. J, K, L. L, M, N. N, O, P. So 2-letter jumps. Make a conjecture for each scenario. The square of an even number. Let's try a couple. 2 squared. -2 is an even number. -2 squared. And 0 counts as an even number. So let's check this. So 0 squared gives me 0, which is an even. 2 squared gives me 4, which is even. -2 squared gives me 4, which is even. An odd even number. So let's see. 6 times 6, 36. 8 times 8, 64. The square of an even number is even, would be my conjecture, and I can't think of a counterexample. Let's look at number 4. The product of a multiple of 2 and a multiple of 3. So let's look at some multiples of 2. Multiples of 2, 2, 4, 6, 8. Multiples of 3, 3, 6, 9, 12. Let's see what we got. Okay, the product of a multiple of 2 and a multiple of 3. 6 times 6 gives me 36. 3 times 4 gives me 12. 3 times 2 gives me 6. 3 times 8 is 24. 12. 12 times 6, 72. They all seem to be even numbers. 12 times, that's 48. About negative multiples. -2 and a 3. That's a -6. That's an even number. So the conjecture is that they are even. Let's look at number 5. Find one counterexample to show each conjecture is false. So let's see how we can shoot these down. For 2 real numbers A and B, A is either equal to B or greater than B. Equal to B or greater than B. Could A be less than B? Let's see. Let's do 2 and 3. So if we let A be 2 and B be 3, A is not equal to B and A is not greater than B. That's a counterexample. So we did that. All quadrilaterals are parallelograms. Now, quadrilateral is a 4-sided polygon. A parallelogram is a 4-sided polygon where opposite sides are parallel and opposite sides are congruent to each other. So let's see. So what about a trapezoid? It looks like this. A trapezoid has one pair of parallel sides, but all the sides aren't parallel. In a parallelogram, opposite sides are all congruent. In a trapezoid, possibly, if it's isosceles trapezoid, these two legs are congruent, but not all sides are congruent. So isosceles trapezoid would be a counterexample. That would be a counterexample. Let's look at number 7. For each conjecture, verify with several more examples or find a counterexample. For a whole number n, n to the third will be odd if n is odd, and even if n is even. Okay. So let's look at 3 to the third. That gives us 27. So here's an odd, comes out odd. Let's look at 2 to the third. That's going to be 8. Starts out even, comes out even. What about, now we're talking about whole numbers. Now remember, the whole numbers start with 0, 1, 2, 3, 4. They don't go into the negatives. Those are the whole numbers. So the counting numbers plus 0 makes the whole numbers. Let's see. Bigger numbers of 15. 15 times 15 is 225. Times another 15, that's going to be too big of a number. 10 times 10 times 10, even, that gives 1,000, that's even. 9 times 9 times 9. 9 times 9 is 81. 81, so 9 to the third is 729. 8 to the third is going to be 64 times 8, which is 512, which is even. So it seems to be true. Consider this statement, number 8. All families go to the movies together. What's required to prove that the statement is false? Find an example of, like, where the daughter or son goes to the movies on the weekend, but the whole family doesn't go. That would be a counterexample. Not everyone goes to the movies at the same time, together. The other thing would be, let's say there's a couple different movies playing, and somebody wants to go see one of the Marvel movies. The other one wants to go see maybe Beetlejuice. Those are two different movies. The family might go to the movies together, but does it count as being together if you go to separate movies? Somebody might go to Rockaway to go to IMAX, and they might go to Morristown to go to the movies there. So they may go to the movies the same day, but they don't necessarily have to go together. So all you have to do is find an instance where they go separate. Let's look at number 9. A farmer keeps track of the water his livestock uses each month. How can he use his data to predict the amount of water used in August? Well, let's look at the differences here. This seems to be a jump from like 1.5 to 3. From 3 to 4.5, another jump of 1.5. Another jump of 1.5. And I would predict, based on the pattern, there's going to be another jump of 1.5. So July would be 7.5. Or August would be 7.5. So that's what I would use, or that's how I would predict maybe what this would actually work out to be. So here's August. And that's the additional practice.